pleasure being here again, speaking about a topic which is very important for all of us to ensure our future. I was speaking about this theme about, I think, 4 or 5 years ago here. Then it was, let's say, too romantic, of too much ahead of time. But I think now it's going to be reality. Well, actually, yes, just a few words from my background. So, from 2 years of age, I started getting involved into construction business. I remember being a small child, still not working, when I was already in my father's office learning how to do design. So it's really in my blood. I took over the company in about '92 and then started expanding it into architecture. So today we are the largest architectural company in Finland. Then to geotechnics, environmental technologies. So actually today with Breakfast team we cover all the disciplines that are needed. One of our special fields is building physics. Which means managing heat, cold, moisture, water. And when we are speaking about sustainability, these play a very important role in lifespan and functionality of the buildings. From early 90s, I've been also involved in drawing up codes of practice and norms in Finland. For renovation, building physics, and lately also for sustainability. Last year I was a member in a ministerial committee which in 1 year time was supposed to leave its proposal for the next government to implement the green building thinking into practice in Finland. And then we covered all the dimensions in the society, starting from legislation to business, to norms, to education, and so on. Really, when we are speaking about sustainability or green building, we have to consider the whole society, because adaptation of the new technologies and a new way of thinking needs basic training, let's say from the first grade already, to form attitudes to support this thinking. Okay, that's about the ideology. Let's go to hard practice. Okay, let's say the challenge for all of us is actually that if we can continue consuming the natural resources with the present speed, we are really running out all the resources within 30 years, and we would need a new globe. There is a challenge much earlier. So within a few years we are running out of some strategic metals which are, for example, used in solar panels or mobile phones. So that is actually also a challenge for us. What kind of green technologies should be applied, which are not dependent on the strategic methods? Okay, what is the background for this green thinking? In the built environment, we have a great potential for savings. So the built environment means housing, hotels, everything. The consumption of energy and use is about 40% in most countries. And also, this built environment buildings produce about 40% of the CO2 emissions, carbon emissions. There are many kinds of international commitments, protocols, agreements to cut down the energy consumption and also the emissions. And one of the stringent is the EU target to cut down the emissions and energy consumption by 2050 till 2050. Tremendously, I don't say the percentage because that is again under discussion what it will be. But anyway, the cutting down the emissions means in practice that all the buildings built from today onwards should be passive buildings, passive houses. Because the building stock renews about 3 to 5% annually. To achieve the targets, most of the European countries have drawn up their own strategies how to achieve these. And as you can see, in many countries, the targets are much and more ambitious than the EU targets. And to reach these targets, there are all kinds of incentives for businesses, for individuals. The first one is funding for energy repairs, renovations, which actually takes place in most of the countries. These are very challenging for the low-income households. That's why there is financial help in most of the countries for these kind of families. And there are green loans, tax deductions, and so on. What started this year was this feed-in tariff, which means that the individual buildings can also produce electricity to the national network. Okay, so let's see the energy consumption, where we were in the history and what is the target. So this is the energy consumption kilowatt hours per square meter annually. The building stock in the 70s used, let's say the variation was very high, so from 150 to 300 kilowatt hours. And I think this is the case also in the old building stock in Russia. Today in Finland we are, or let's say, we were in the average of 100, 120. And now we are going down to between 50 to 70, which is a passive house. And the target is to go down to zero energy house, which means that it consumes, but it also produces energy. And then, of course, the final target is to have plus energy houses which produce energy. The real challenge in zero energy houses and plus energy houses is how to store the energy that the buildings produce. If we use solar energy, let's say having solar panels, this production takes place from March till September, October. But the consumption has its peaks during the winter time when there is no production of electricity or energy. There are ways of storing the energy, which we see a little later on. In many countries, there is also talk of having so-called eco-cities. The first eco-city in the world is Masdar city in Abu Dhabi. That's going to be a city for about 20,000 inhabitants. The first phase is already finished last year. We are also opening our office here in this month, or let's say in June. Masdar city has the target of being zero energy and zero emission city. They use a lot of solar energy by having the solar panels, and they have excess production of electricity, so that they sell it to the Abu Dhabi city. Also, they collect the solar energy this way, so that actually the tower can have a traditional turbine producing heat, but also electricity. And as you see, this kind of power plants are being built around the world. Also, they are making and drilling holes down to 2 kilometers to use the geothermal energy. And in this case, they want to use the geothermal energy for producing electricity. And that means that we have to go so deep that the temperature is over 140 degrees. This kind of electricity production exists already in the US, for example. And if we can't reach this high temperatures, then we can use the geothermal energy for heating and for cooling, which I'm going to talk later on. Also in Mastor, they have started using old technologies and integrating those into modern technologies. You see a wind tower in the middle, and wind towers are very traditional in the old Islamic buildings. They create a natural ventilation because air heats up in the tower. And that creates a very effective ventilation just above the pedestrian areas and so on here. So you have a cooling breeze all the time. Actually, I think that is a real challenge in the green thinking and sustainability. To adapt the traditional methods which we have been using in Russia and in Finland, and integrate those into the modern technologies. Let's say till the 50s, we used the natural phenomena for cooling or for heating. But from the 60s onwards, we actually started fighting against the natural phenomena. And also then the energy consumption started getting higher and higher. Also in Masdar city, they are using this kind of small electrical vans. No ordinary vehicles are allowed in the city area. Okay, let's go into key areas that we have to focus in green thinking. First of all, we have the question of production and management of energy and distribution of energy. And the trend seems to be that we have to have all the time more and more production. To fulfill the demand. But in practice we know that by managing the demand we can also cut down the need for production. So managing demand of electricity, heating, cooling and water. And then we come to the individual buildings, actually. And also what is in real practice is how to manage the individual consumer behavior. Because all individuals actually make the decisions based on what is easy. So the design of a building should be done in such a way that the easiest way to use the building is also the most sustainable way. Then of course we can manage the individual consumer behavior by legislation, taxation and so on. Then of course one key area is the environmental load. It is not only the CO2 and methane, it is all other loads to the environment. And then one more area is the natural resources. Which resources are really going to be scarce in the coming years? The last one, which is more and more stressed, is the quality of life. Because of course we know that people are much more eager to adapt the energy saving and let's say different way of living if quality of life is improved. Actually, can you all hear the translation in Russian? Does it work? It works. Okay, good. Okay. And especially the Japanese, they stress the quality of life because they have seen that that is actually the key topic to get through this ideology. Okay, then I'll go to comparison here between Helsinki and Oradea in northwest of Romania. We have office also in Bucharest, and that's why we have this kind of comparison done. So, as Guy said, here we can see the elephant. In Helsinki, the days that need heating is 250 and Oradea 150. Then when we consider a normal apartment of 60 square meters, in this kind of apartment, the heat consumption, annual heat consumption in Helsinki is about 9,000 kilowatt hours. And also in Oradea it's about 9,000. Even though the days needing heating is much lower. And then there is the elephant, the network losses. In Helsinki about 600 and in Oradea almost 4,000. Then production losses. In Helsinki about 2,000, in Oradea 7,000 to 8,000. Fuel consumption in Oradea 2 times higher. And then we come to the total efficiency, which in Helsinki is 85%. And in Oradea about 40%. So this shows where actually really the elephant is in the production efficiency and also in the distribution efficiency. The production losses are due to leakages in the network. Also, the water temperature is much higher in the Oradea than in the Helsinki network. Also, the insulation of the distribution network is poor. And balancing of the network is not actually done. But anyway, even though the distribution network is the main focus, there is still reason to focus also the individual buildings, how to manage those. The Oradea figures are about the same as in St. Petersburg. And I don't think Moscow differs a lot from these figures. I haven't seen actually any figures from Moscow if somebody knows if there are these kind of figures, I would really like to see those. Okay, then let's go to individual buildings. When we are speaking about sustainability, we are speaking about energy savings, but we are also speaking about good indoor air quality, which means that it's healthy living. And the key factor to both these is that the building envelope is airproof. If we have this kind of leakages, air leakages through the structures, it means that all impurities are sucked into the indoor air. Also, we know that there are impurities in the insulation, bacteria, fungus, and so on. Dust, and also those are sucked into the indoor air. Also, these air leakages form cold ridges, which means that there can be condensation of indoor air vapor into the structures. Okay, that's one key, and I think already in this respect there is a lot of potential in the present way of construction. Okay. When we are speaking about district heating in Helsinki, we are also speaking about district cooling. Here in Moscow and in most cities and countries, we can see a lot of this kind of installation, let's say machinery on the facades all over, for cooling down the premises. In Helsinki, the solution is to have a district cooling network, which is very effective, and also the costs are reasonable. And with this kind of centralized cooling system, we can use seawater, for example, as the resource of the cooling energy. Then, on the other hand, we can use the geothermal energy for cooling and for heating. And in these web areas, which are very active, there is a high potential to use the geothermal energy also for electricity production. But in all other areas, we can use the geothermal energy for heating and cooling. And the reason is that inside the Earth, the temperature is about stable, and when we are in Russia, it is somewhere between 4 to 10 degrees. And that is enough, of course, for cooling, but also for heat. Then we come to the question of storage. Well, we have this kind of system that we have heating and we have cooling in the same system. In summertime, when it's hot, we can use the energy for heat, for cooling. And it means that, okay, we take the coolness of the earth, and we return the hot energy to the subsoil. So the ground is the storage. In wintertime it works in different ways, but then we use the heat energy, hot energy, which we have stored there, and we return the cold energy and store it. Actually, that's the way that also quite large buildings have been done during the recent years. And for the moment, most of the private villas, private buildings, houses are built this way. And in these small houses, we can use the horizontal closed loops, or the vertical loops, which go down to 100, 200, 300 meters, depending on the subsoil conditions. A few years ago, we had this kind of project somewhere north of St. Petersburg, and I've been trying to remember the name of the place, but I can't remember it. But it was a project of I think 12 villas. 12 villas. The investment cost of this kind of system, the payback time is about 5 to 7 years. And after that, of course, the cost is quite low. Okay. Well, this kind of system we have used, for example, or let's say a resemblance system we have used in some sport halls. So this is a sport hall with artificial ice skating rink for hockey. Okay, and of course, when we need a lot of cold energy for making the ice, freezing the ice. Then we also produce a lot of heat, hot energy. That is used for heating water, and also can be used for heating, let's say, the ventilation air and so on. So actually no energy losses take place. We have made benchmarking with the, let's say, the US systems, how they make this kind of sport halls in the US. They have separate systems for making the ice and separate system for heating up. So the energy consumption is actually twice as high. So this kind of thinking is taking place more and more. Okay, then ventilation is actually one of the main reasons for energy losses in buildings. There are many kinds of technologies to use this ventilation energy. Juha Pihlajamäki is going into details. Juha Pihlajamäki is going into details in his presentation. On how to recover the heat from the ventilation air. But as you can see, with some systems, up to 90% of energy in the exhaust air can be recovered. Okay, I spoke about the airproofness of the building. That is one theme. Then the other aspect is that energy efficient buildings and structures have to be physical functional. We have moisture coming from rain, from external humidity. There is moisture in the subsoil. There is humidity indoors, which can condense into the structures. So, one of the keys is how to manage the physical loads. And one interesting dimension is that the climate has been changing so rapidly that the traditional detailing for example, facades and roofs, they don't function anymore. So design has been copy and paste. If we copy the old types, we will not be successful. Here is yes, related to the humidity. One key question is, are the structures able to dry out? Because during the installation, during the construction phase, we bring a lot of moisture into the building. We have concrete, we have all kinds of plasters. Then there is rainwater coming and snow. So is the building, are the structures able to dry out fast enough? Here is an example. We have a plastering, let's say thermoplaster, meaning that there is insulation. Thermoplaster, meaning insulation and then plaster on top. And during the execution phase, some moisture has been coming into this layer. Then with different kind of structures, we have made simulation what happens. And with certain materials, we can see that the dry out time is so long that humus growth starts taking place. And why this is important is that when we are making energy efficient buildings, we are all the time increasing the thickness of insulation. And when we are increasing the thickness in insulation, also the drying out time usually gets longer. The result can be this. In this building in Sweden, the dry out time has been too long, and you can see that there is a lot of humus in the structure. Or when we have this kind of brickwork structure, which is very common in Russia, the facades. We know from practice that it is not waterproof. So after a rain of 10 to 15 minutes, there is water going through the brickwork, running down, and the structures are getting wet. And it's very typical to have a slab coming to the facade, and the brickwork starting from the edge of the slab. So from practice we know that these places are going to be moist and wet, and there is going to be humus growth. And as a result, we will have also thick building with poor indoor air quality. So when we are speaking about sustainability, cold bridges like this slab coming to the facade are not allowed. And also we have to manage the water so that it doesn't cause problems. Also, if the insulation is wet or moist, the insulation capacity is much lower. Okay, I'll pass this. Then, when we have a passive or low energy building, being that the facades and the roof are quite good insulated, the windows are actually then playing a very important role. The energy loss through the windows is actually one of the highest when we consider the whole envelope of the building. The Russian norm target is about twice as ineffective as the demand in norms in Finland. Now, today we have very efficient window systems with two double glazings, special gases in between. And with this kind of window systems, we can go, let's say, to 1/3 of the energy consumption than what is the target in the Russian norm. Okay, then we go to the facade systems and insulations. Here it is airtight, vapor open and reflective. I've spoken about the two first ones, and now we go to the reflective dimension. So the trend is going into more intelligent facade structures, where we can have, for example, layers of materials which change the phase. This changing phase means that if we have water is one phase and ice is another phase. So this kind of materials can be some kind of, for example, wax. When it is too hot, the wax absorbs and stores the heat. And when it gets colder, it releases the heat. And then we can have also different kind of reflecting layers in the structure. And in that way, we can actually cut down the heat flow through the facade. Let's say, I don't even know how much, but anyway, 80% of the present situation. So I would say that these are going to be more and more intelligent. And when we are speaking about intelligent structures, we have developed this kind of intelligent roof system a few years ago in our company. It means that we use the daytime heat and the nighttime low temperatures and store the heat and the coldness in the structure. It means that we have a dynamic structure where we can change the properties of the insulation. So during the night time, this surface temperature is usually 5 to 7 degrees lower than the temperature in the ambient air. So we store the coolness in the concrete slab. And by daytime we release this coolness into the air. This kind of intelligent structures, I think they are getting more and more common. And there we use natural phenomena, which I spoke earlier about. Okay, then we are speaking all the time of increasing the thickness of insulation. We can see that when we go to certain thicknesses, the thickness, the increase of the thickness is perhaps not anymore feasible. For example, from 300 to 400 millimeters, we reach a really low difference in the insulation capacity. So we have to optimize the properties and thickness of the insulation, and actually focus more in the total consumption of energy of the building. Okay, there are many kinds of new insulations coming to the market. Vacuum insulations, which have been used quite a long time in the car industry. Are very efficient, as we can see, compared to, for example, to polystyrene or polyurethane here. And these can be combined, as there are some, let's say, more conventional insulation materials which may have a layer of this kind of vacuum insulation inside. It means that instead of having 300 millimeters of mineral wool, we can have perhaps 150 millimeters of this kind of modern insulation. Okay, we have in Finland, in our company, we have made this kind of libraries for the modern insulation materials, and that is because we have our own laboratory and research development work, and we do quite a lot of research to these companies. Then there is also this kind of aerial, which means that it is solid smoke. It's pretty like smoke, which is solid. Very light, very effective in insulation. Still quite expensive, but getting more and more feasible also in the construction. Then the old-fashioned, let's say, foam glass and other materials are coming also back to the market. Because we want to cut down the waste material, meaning that we also recycle glass. all the recycled glass could be used for making foam glass, which is very effective as insulation. One very interesting, I think, challenge is how to improve the insulation or energy efficiency of old buildings. Like this. Because we can't install any additional insulation externally. In this kind of building, if we install internally mineral wool or polyurethane or anything like that, we are sure to have problems. Because that causes condension and fungus growth. But there are some materials which can be used also for internal additional insulation. They are very open in the board structure. They are very open in board structure. Yes. Okay, then I spoke already about the materials with the phase change properties. Which can look like just ordinary material, but they can have some cells like wax and so on, which change effects and store energy. This is quite a common phenomenon in St. Petersburg and in Moscow. When we don't have good insulation, we don't have good ventilation in the roof, we have air leaks. As a result, the snow starts melting, form ice down here. We have water, pond actually, and then we have leaks in the structures. So, let's say in an energy efficient building, we can avoid these problems. But always we have to remember that there has to be a good ventilation in the structure. Also we have to remember that if we have air leaks, good ventilation can result in more problems. Then how can we influence water consumption? There are this kind of systems where grey waters are recycled. This technology is actually Finnish-based. It is used in airplanes. Let's say in a traditional toilet, each flush consumes from 6 to 9, 10 liters of water. In this kind of system, the water consumption can be 85%, let's say 80–85% lower. This technology is applied, for example, in the airport terminal at Heathrow, where 20,000 people use the toilets every day. So in 1 year, 9 million liters of water is saved. This is technology which is applicable also to individual buildings, but I would say that they are more efficient in buildings where you have a lot of people, like airport terminals or some sport arenas or so on. Okay, then we are coming to the closing up of my presentation. Now, Actually, today we have all the technologies that are needed for green building. The challenge is actually to manage the processes and projects in such a way that the know-how is integrated in the right way. And it means that in a very early phase, when we are making the concept of the building, we have to have the right people with the right know-how to make an integrated concept. If we are doing, let's say, this kind of thinking at the working drawing phase, we are too late. This means that also integrating the know-how means that in traditional way we have the different disciplines for different designs. Also, the traditional way of making the construction is to divide it into let's say, between many players. The outcome is these small islands and no one can manage that. So I would say that with this traditional way of running the construction business, we don't have any chance of having successful green buildings. We have to plan the process, how we manage that, and then how in this process we integrate the green technologies. In Finland, the tool for this is building information modeling. Which means that all the design is integrated into one electrical model. And you can manage also the timetables and everything with this kind of system. And into this kind of system you can also add the control of the building, it can be fire safety, but also in the intelligent buildings it can include managing the intelligent systems of the building. That is actually already present today in some processes in Finland. Also with this you can make simulations, they can be energy simulations or they can be then flow simulations. For example, simulation of wind, influence of wind. All kind of thermodynamic, moist, acoustic simulations. And with this you can simulate the behavior of the building up to, let's say, 20-30 years as you wish. This is one example. We have made simulation how this kind of roof behaves and how the ventilation of the roof actually functions. Okay, this is one of the last slides. Now, at this stage of new technologies, we are quite a lot in the component manufacturing. We have different kind of technical solutions for individual purposes. Some producers are going to system deliveries, like for example a whole facade system. The target should be performance contracting, and then connected with life cycle management, then we are, I think, where we should be in the future. Performance contracting means that the client, with his experts, make the definition what kind of building does he want to have, what kind of features, what kind of energy consumption, what kind of water consumption, and then based on this, the model is done. And then when we take into account life cycle management, which means taking into account the lifespan or service life of the different materials and structures, then we will have also economical outcome. There are these kind of ideas all around the world, eco-buildings, eco-cities. This is Eco-Garden St. Petersburg. In China, they have a lot of these kind of old towns, eco-cities taking place. And the master city, which I spoke about, is actually the guideline for all of these.